Have you ever marveled at the variety of cat colors? From the common black, white, and ginger to the more rare like chocolate, cinnamon, and cream, the world of cat coats is a vibrant spectrum of hues and patterns. But did you know that these colors are not just a matter of aesthetics? They are the result of complex genetics. In the heart of every feline's fur color are three main pigments. First, we have eumelanin, responsible for the rich black and brown shades. Then there's pheomelanin, the artist behind the fiery red and warm yellow hues. And lastly, the agouti signal protein, the master of the banding pattern, creating an array of stripes and spots. So next time you find yourself admiring a cat's coat, remember it's more than just a pretty pattern. It's a testament to the intricate workings of genetics. Unraveling the mystery of cat colors starts with understanding these basic genetic elements. How do genetics dictate the color of a cat's coat? Well, it all starts with the genes. Each cat carries two types of pigments in their genes: eumelanin, which gives a black or brown color, and pheomelanin, which creates a red or yellow hue. However, the story doesn't end there. The distribution and intensity of these pigments are also controlled by other genes. This is why we see a wide array of colors and patterns in cats' fur. Let's delve deeper into this fascinating genetic mechanism. Think of genes as a set of instructions for making pigments. When a kitten is conceived, it gets one set of color genes from each parent. The combination of these genes will determine the color of the kitten's coat. For instance, if a kitten inherits two genes for black pigment, it will be black. But if it inherits one gene for black and one for red, it will be a tortoiseshell, displaying both colors in its coat. Now, let's talk about white fur. This is where things get even more interesting. White fur isn't caused by a lack of pigment, but by a gene that masks the other colors. This gene, known as the white masking gene, inhibits the production of pigments, resulting in a white coat. So far, we've talked about solid colors. But what about patterns? Patterns in a cat's coat, like stripes or spots, are also dictated by genes. These genes control where, when, and how much pigment is deposited in the fur. For example, the agouti gene causes hairs to have bands of color, leading to a tabby pattern. On the other hand, the non-agouti gene leads to a solid color coat because it causes the hair to be a single color all the way down. So, there you have it. The color and pattern of a cat's coat are determined by a fascinating interplay of genes. The result is the beautiful and diverse array of feline colors and patterns we see today. So, the next time you see a cat, remember that its unique coat color is a beautiful display of genetic artistry. So, what are some of the rarest cat colors and patterns out there? Dive into the world of chocolate, cinnamon, and lilac feline fur. These colors might sound like items on a dessert menu, but they're actually some of the most unique hues you can find in a cat's coat. Chocolate, for instance, is a rich, deep brown that's as warm as a cup of cocoa. Cinnamon, on the other hand, is a reddish-brown color that's as spicy as the spice itself. And lilac? It's a diluted chocolate color, a sublime blend of gray and pink, as delicate as the flower it's named after. But why are these colors so rare? Well, it's all down to genetics. Each of these hues is controlled by a recessive gene. This means that a cat needs to inherit two copies of the gene, one from each parent, to express the color. If the cat only gets one copy, it won't show up in their coat. This makes these colors quite rare, as both parents must carry the recessive gene. Now let's talk patterns. Ticked, rosetted, and marbled are some of the most unique designs you'll see gracing a cat's coat. A ticked pattern, for example, is when each hair is striped with multiple colors, creating a sort of salt and pepper effect. Rosetted patterns, meanwhile, are reminiscent of a leopard's spots, with clusters of dark fur surrounded by a lighter halo. And marbled? It's a swirl of colors, like a marble cake, with patches of light and dark fur mixed together. These patterns are also the result of complex genetic interactions. Some patterns are dominant, meaning they'll show up even if a cat only inherits one copy of the gene. Others are recessive and require two copies to be visible. In the end, the array of cat colors and patterns is a testament to the wonder of genetics. It's like a painter's palette, with each cat being a unique work of art. These rare colors and patterns make each cat truly one of a kind. Isn't it fascinating how genetics can create such a variety of cat colors? We've journeyed through the vibrant world of cat coats, delved into the science behind these colors, and admired the uniqueness of rare patterns. From the common tabby to the elusive lilac, every hue and pattern is a marvel of nature's genetic workshop. So next time you gaze at your feline friend, remember, each strand of fur is a testament to the wonders of genetics. Whether your cat is a common tabby or a rare lilac, remember that its coat color is a testament to the wonders of genetics.